So today I will explain about the anatomy of the digestive tract. So first is the mouth, which is the place where the process of the digestion begins. So during chewing, teeth crush large pieces of food into smaller ones, and fluid from the food, beverage, and salivary glands blend with this piece to ease swallowing. So the tongue provides the taste sensation and move food around the mouth, facilitating chewing and swallowing. So the food passes through the pharynx, a short tube shared by both digestive system and respiratory system. Epigastric cross off the airway, avoid choking when swallowing. So next is the esophagus. Esophagus is when during the swallowing, the upper esophageal sphincter will open. So the bolus, which a portion of the food when you swallow, will slide down the esophagus, which passes through a hole in the diaphragm to stomach. The lower esophageal sphincter at the entrance to stomach crosses behind the bolus so that it proceeds forward and does not slip back to the esophagus. Little by little, stomach transfers food to the lower portion, adjusts to it, brings it to a semi-liquid mass called chyme. Bit by bit, stomach releases the chyme through the pyloric sphincter, which opens small intestine and then crosses after the chyme goes into the small intestine. So at the beginning of the small intestine, chyme bypass the opening from the common bile duct, which dripping fluid into the small intestine from two organs outside the GI tract, which is the gallbladder and the pancreas. So when the chyme travels down the small intestine through its three segments, duodenum, jejunum, and ileum. So for the last part is the large intestine, which is colon. So in the colon, it will withdraw the water from the food, leaving the semi-solid waste. So the strong muscle of the rectum and the anal canal will hold back this waste until it's the time to defecate. So then the rectal muscle relax, two sphincter of anus open and allow the passes of the waste to go out from our body.
Okay, now I will present about the muscular action of digestion. The small intestine has two muscle layers, which is circular muscles and longitudinal muscles. The circular muscles are inside and the longitudinal muscles are outside. The two muscle layers are work together in peristalsis and segmentation. In the peristalsis, the circular muscle will contract and tighten the tube and will push the food, the chyme, forward in the intestine. Next is the circular muscles will relax and the longitudinal muscles will contract and the intestinal tube is loose. Circular and longitudinal muscles will tighten and relax. Chyme will move a tip of the contraction. Next is the segmentation. The circular muscles will contract and create many segments in the intestine. The set of the circular muscles will relax and contract. The chyme is broken up and mixed with the digestive juice. The alternating contraction will occur 12 to 16 times per minute and continue mix chyme and bring nutrients into contact with the intestinal lining for absorption. Next is the sphincter contraction. The sphincter muscles will allow contents of GI tract move along from esophagus to stomach. The upper esophageal sphincter will open for swallowing, and the lower esophageal sphincter will prevent the reflux of stomach contents. Next is the stomach action. The stomach has three muscle layers, which is longitudinal, circular, and diagonal. The three sets of muscles will work together and force the chyme downward, but the pyloric sphincter will remain tightly closed and prevent the chyme pass into the duodenum. So the chyme will remain in the stomach, and at the same time, stomach will release the gastric juice. And next, when the chyme is completely liquefied with the gastric juice, the pyloric sphincter will allow the chyme pass through in the intestine. Now I will explain the sequences of digestion. Breaking down food in nutrients need the secretions from 5 different organs, which is salivary glands, stomach, small intestine, pancreas, and liver. When the food moves into the salivary glands, it will square the enough saliva to moisten each mouthful of food, so the food easily passes down the esophagus. The function of the saliva is initiate the digestion of carbohydrate. When the food moves into the stomach, gastric glands will secrete the gastric juice. The juice contains mixture of the water, enzyme, and hydrochloric acid. The hydrochloric acid will cause secretions of carbons if hydrochloric acid reflux to esophagus. The hydrochloric acid also will destroy the cell of the stomach. The cell of the stomach wall will secrete the mucus. This mucus can protect them from acid, enzyme, and disease-causing bacteria that may cause harm. For the small intestine, by the time food leaves the stomach, digestion of all 3 energy nutrients, which is carbohydrate, fat, and protein, has begun, and begin the actions of gain momentum in small intestine. For the pancreas will contribute digestive juice by way of thus leading into duodenum. The pancreatic juice contains enzyme that acts on all 3 energy nutrients. The cells of intestine wall also possess digestive enzyme on the surface. The pancreatic juice contains sodium bicarbonate, which is basic or alkaline. The pancreatic juice can neutralize the acid chem in small intestine from stomach, so the chem can remain at neutral or slightly alkaline pH. Next is liver. The liver continues produce bile, which is concentrated and stored in the gallbladder. The bile also flow into the duodenum. Bile acts as an emulsifier that can bring the fat into suspensions in water, so the enzyme can break down into their component parts.
The final stage of digestion. All the 3 energy-yielding nutrients such as carbohydrate, fat, and proteins have been digested and ready to be absorbed. The undigested residues such as fibers are not absorbed. Instead, they flow through the digestive tracts, carrying the mineral, bile acids, additives, and contaminants out of the body. The semi-solid mass, which is the undigested residues, helps exercise the GI muscles and keeps them strong to perform peristalsis efficiently. The fiber also retains water, accounting for the consistency of food, which is the feces. By the time the contents of the GI tract reach the end of the small intestine, little remains but water, a few dissolved salts, and fibers. All of these remaining enter the large intestine. In the colon, intestinal bacteria ferment some fiber, producing water, gas, and small fragments of fats that provides energy for the cells of the colon. The colon retrieves all the materials that the body can recycle, water, and dissolved salts. The waste that is excreted has little or nothing of value left in it.
So the last part is the absorption of nutrients. So actually absorption means that within 3 or 4 hours after we eat some food, our body must find a way to absorb the molecules derived from carbohydrate, protein, fat, vitamin, and mineral. The absorption is take place in small intestine. So the small intestine is wrinkled into hundreds of folds, and each fold is contoured into thousands of finger-like projections, which we call as villi. So the villi is composed of hundreds of cells covered with microscopic hairs. We call it as microvilli. So in the crevice between the villi lies the crypts, which is the tubular glands that secrete intestinal juice into small intestine. And the villi also consists of globular cells which secrete mucus. The villi are in constant motion. It is lined by thin sheet of muscle, so it can wave, scream, and wriggle. Any nutrient molecules that is small enough to be absorbed is trapped among the microvilli and then will drawn into the cell. However, but the partially digested nutrients will digest further by the enzyme first and then absorbed into the cell. So you can see the picture here. This is the small intestine, and then this is the villi. Here got the circular muscle and then the longitudinal muscle which can make it move. So each villus will consist of lacteal at the middle, and it is consists of the globular cells, and then each cells, the surface of the cell will consist of the microvilli. So the absorption of nutrients into intestinal cells is actually occurs by simple diffusion, facilitated diffusion, and active transport. The large molecule is absorbed by endocytosis. So this is the simple diffusion which follow the concentration gradient from high concentration gradient to low concentration gradient. And the example of simple diffusion is water and small lipid. So here is the facilitated diffusion. The example of nutrient that will pass through by the facilitated diffusion is the water-soluble vitamin. And the facilitated diffusion needs specific carrier to transport. For the active transport, it also needs the carrier to transport, but it is against the concentration gradient and it requires energy. So when a nutrient molecule has crossed the cell of the villus, it enters either the bloodstream or the lymphatic system. Water-soluble nutrients and smaller product of fat digestion are released directly into the bloodstream and guided directly to the liver. But for the larger fats and fat-soluble vitamins are insoluble in water. So the intestinal cells will assemble many of the products of fat digestion into larger molecules. This larger molecule will cluster together with special protein forming cyclomicrons. Since the cyclomicrons cannot pass into the capillaries, they are released into the lymphatic system and then move through the lymph and later enter the bloodstream.